Let's take a look at the 11th question, guys. It says the coefficients of the term independent of x in the expansion of this given term is.
Yes. So the given expression is a bit complicated.
Right.
So there's nothing to worry about it. So how can we simplify this equation? So let's get some clue. Okay. So here there is x raised to 1 by 3 and here is x. So if x plus 1 is multiple of x raised to this denominator,
Right.
then we can probably cancel this. So
Sure.
x square x raised to 1 by 3 whole square minus x raised to 1 by 3 plus 1. This is it is like it is a one term in x plus 1 this expansion a cube plus b cube. So x raised to 1 by 3 whole cube plus 1. If we expand this, we will get x plus 1 x raised to 1 by 3 plus 1 into x raised to 2 by 3 minus x raised to 1 by 3 plus 1.
Right.
So x plus 1 can be simplified in the form of x raised to 2 by 3 minus x raised to 1 by 3 plus 1.
Correct.
So that we can eliminate this denominator. So x plus 1 is equals to this term. So first term we will get it as x raised to 1 by 3 plus 1.
Right.
Second term will be equals to x minus 1 by will get root x outside. So root x minus 1. So we'll write x minus 1 it as root x plus 1 into root x minus 1.
Correct. In the form of a
Yes.
square plus b square.
Yes,
a square
yes.
minus b square.
Yes.
Right.
So root x and root x minus 1 will get cancelled from numerator and denominator.
Right.
So we'll get 1 plus 1 by root x. So the given binomial expression will become it as x, the first term will be x cube x raised to 1 by 3 plus 1 minus 1 plus 1 by root x
Right.
whole raised to n 10. Okay, so 10. So we'll simplify it further. X raised to 1 by 3, this 1 and 1 will get cancelled. So x raised to 1 by 3 minus 1 by x raised to 1 by 2.
Right.
So whole raised to 10. So we'll just expand this. Expand means we'll see general term. So TR is equals to 10 CR into x raised to 1 by 3 whole raised to 10 minus r into minus 1 by root x whole
Right.
raised to r.
Hmm.
So what is the power of x in the general term? So 10 CR into x raised to 10 minus r by 3 minus this r by 2 into minus 1 whole raised to r.
Right.
So minus 1 whole raised to r into 10 CR into x raised to 10 minus r by 3 minus r by 2. Since we
Right.
want the term independent of x, coefficient independent of x. So 10 minus r by 3 is equals to r by 2.
Right.
So 20 minus 2r is equals to 3r. So r will be is equals to 5. So if we put r is equals to 5, the
Won't r be equal to 4 if you solve the equation?
Yes, sorry. R is equals to 4. Sorry.
All right. So all you did was you made the exponent of x equal to 0 since you wanted the term to be independent of x.
Exactly.
Right.
So we'll substitute it in general term.
Okay.
So just put r is equals to 4. So term will become 10c4 into x
Right.
raised to 0 since we want the term independent of x. So minus 1 whole raised to 4.
Right.
This will become it as 10c4. So this is the term independent of x.
All right.
Yes, in this expression. So the key concept was, if we see the term in the bracket, we'll get confused to how to simplify it. Just look at the denominator and numerator and try to find some relation between them so that denominator will cancel out.
Right.
This was the only one very good concept in this problem.
Okay, guys, we'll move on to the next question now. Guys, here's question number 12 for you, which says if x is real and s equals 1 minus c1, 1 plus x upon 1 plus nx plus c2, 1 plus 2x upon 1 plus nx whole square, and so on, this is a sum of terms up to n plus 1 terms with alternating positive and negative signs. Your job is to find the value of s.
Yes. So main point in this question is 1 plus nx. The power of 1 plus nx is increasing from 0 to up to n plus n. Okay. So we'll put 1 by 1 plus nx as this is equals to y. Y is some other coefficient.
Right.
It is equals
You're trying to
one.
simplify things, right?
Yes.
Hmm.
To avoid more calculations. So s will be equals to 1 minus c1, 1 plus x into y plus c2, 1 plus 2x into y square,
Right.
like this. So s will be equals to, we'll multiply y into the bracket. So we'll get two series by
Okay.
multiplying the term with x and with 1. So
Right.
1 minus c1y plus c2y square, like this, plus we'll multiply this y by second term, okay, in every bracket. So
Right.
minus c1 xy plus c2 2xy square, like this. So the first bracket is obviously the binomial
Simple
bi-
binomial
bin-
expression.
yes,
Yeah.
expression 1 minus y whole raised to n.
Right.
So plus this will get xy will get common out from the bracket. So xy into minus c1 plus 2c2y minus, like this. So
Right.
after saying this sequence, we'll get an idea like the term in this term 1 minus y whole 1 minus x whole raised to n is equals to nc naught plus nc naught minus nc1 x raised to 1, like this. So if we differentiate this, the power of x is decreasing by 1 and it is the initial power of x is getting multiplied by it, the binomial coefficient.
Right.
So here the definitely the differentiation of this 1 minus x whole raised to n is equals to this series.
Right.
So 1 minus y whole raised to n, this expression s will become 1 minus y whole raised to n into xy in bracket d by dy. This is differentiated with respect to y. Okay. So 1 minus y whole raised to n.
Correct.
So 1 minus y whole raised to n plus n xy in bracket n into 1 minus y. The coefficient of y is minus, so we'll multiply it by minus 1.
Right.
So after getting we'll ये कॉमन निकालेंगे 1 minus y whole raised to n minus 1 कॉमन निकालेंगे 1 minus y whole raised to n minus 1 in bracket 1 minus y plus n xy actually minus n xy.
क्योंकि वो -1 साइन है वहाँ पे.
ये minus 1 है इसीलिए. So 1 minus y whole raised to n minus 1 and इसके आगे तो बस रीअरेंजिंग है. तो 1 minus ये इसमें से y कॉमन निकालेंगे, y in bracket 1 plus nx and just put the value of y. So we'll get is equals to 1 minus y into whole raised to n minus 1 in bracket 1 minus 1 by 1 plus nx into 1 plus nx.
Right.
So we'll get it as 1 and ultimately this bracket is becoming 0. So
Right.
the value of s is going to be 0. So
Okay.
value of s is 0 actually. So this was the question, and the main part of the question was invoking some other variable like y in terms of 1 by 1 plus nx.
Right.
So we can make this series very in the quite simplified form.
Right. Okay guys, we'll move on to the next question now. Guys, so question number 13 for you is a fairly simple one. Find the last two digits of 17 to the power 10. It looks to be simple, but it could be tricky.
Yes. So the main part is last two. We have to find last two digits of 17 whole raised to 10.
Right.
So अगर हमें last two digit चाहिए तो अगर ये नंबर का अगर इसका हम expansion लिखेंगे like some number plus this some number.
Right.
If this number is multiple of 100, means the last two digits are going to be come from this term only.
Right. The last two digits of the second number.
Yes, yes. So if 7 like x minus 1 whole raised to n, this is equals to nx minus nx, not nx, n kx minus 1.
Right.
If some part of kx is multiple of 100, then we can simplify it further. Okay. So let's see. So 17 whole raised to 10.
Right.
How can we get, if x is multiple of 10, then we can get some part of kx is multiple of 100.
Right.
So 17 whole square is equals to 289. This is the main clue. So we'll get to multiply and divide 10 by 2. So 17 into 10 into 2 by 2. So this is equals to 17 whole square whole raised to 5.
Right.
So this is equals to 289 whole raised to 5.
Right.
And this gives us 290 minus 1 whole raised to 5. So now this question is being simpler. So we'll expand this binomial expression. So 5 C0 290 whole raised to 5 minus 1 whole raised to 0 plus 5 C1 290 whole raised to 4 minus 1 whole raised to 1 like this.
Right.
Plus 5 C4 290 into minus 1 whole raised to 4 plus 5C5 290 into 290 whole raised to 0 into minus 1 whole raised to 5.
Correct.
So the term from 290 whole raised to 5 to 290 whole raised to 2 all are multiple of 100. So we can write it as 100 into some constant k plus 5C4 into 290 into minus 1 whole raised to 4 is 1 actually. Yeah. So minus this 5C5 is 1, 290 whole raised to 0 is 1 and minus 1 whole raised to 5 is minus 1. So we'll write it as this. So 100k plus 5C4 is 5 actually. Yeah. So 5 into 290 minus 1. So this is equals to 100 into k plus 0 into 5 into 4. So 1450 minus 1.
Right.
So 100k plus 1449.
Right. So clearly our last two digits would be 49.
Yes. So 100k. This term number will be like some numbers into 100 plus 1449. Right. The last two digits are going to come from this two. So the summation of these two numbers will be ultimately will be equals to some numbers into and at last 49. So last two digits are 49. So main catch of this problem is which power of 17 makes closer to the number which is divisible by 10.
Okay, guys, we'll move on to the last question now.